Today we are going to look at the sum and the product of the roots. Now, these are formula based, and if you can remember the formulas, it makes the problem much easier. This ends up being on almost every single Regents every year, so it's important that you know how to do this stuff. It says we can use the roots of a quadratic equation to find the original quadratic equation. Recall our general form of the quadratic equation. The sum of our roots will equal negative b over a. The product of the roots will equal c over a. You will have to memorize these. The way I can remember which one is which, product has a c in it, so this formula has a c in it. And then you just kind of have to remember the sum is the other one. First three aren't too bad. We want to find the sum and the product of the roots. To find the sum of the roots, I'm just going to abbreviate with s, you have to take the negative b over a. Well, negative b in this problem is negative 1. A is a 1. So the sum is equal to negative 1. Product is equal to c over a. In this case, the c value is 1 and the a value is 1. 1 over 1 is 1. So the sum of the roots is negative 1 and the product is 1. Same idea here. Sum is going to be negative b over a, so 6 over 3, which is 2. The product is going to be c over a, so it's going to be 4 over 3, which doesn't reduce. This next one you have to make sure it's set equal to 0 first, so I'm going to move the 8x and the 12 to the other side, so I'll subtract the 8x, subtract the 12. Then we can find the sum using negative b over a, so it's going to be 8 over 1, which is 8. You can find the product, which is c over a, negative 12 over 1, which is negative 12. So that type's not too bad. Just make sure the equation is set equal to 0, and then use your formulas. This next piece, I give you one of the roots. In this case, for the first one, one of the roots is negative 3. I need you to find the other root and find the value of c. So, to find the other root, since we are given an a and a b value, I'm going to use the fact that I know the sum of my roots is going to equal negative b over a, or it's going to equal 8. Therefore, if the sum needs to equal 8, I know my one root plus my missing root has to equal 8. Solving for x, add the 3. My other root is 11. Now to find the value of c. What I can do is find the product of the roots. Product means multiply. 11 times negative 3 is negative 33. That means the product of my roots is negative 33, and that has to equal c over a. C over 1 in this case. Solve for c by cross multiplication. You get c equals negative 33. Let's do another one of those for practice. Okay? So, in this case, to find the other root, I know that the sum is going to equal negative b over a. So, negative 5/4. That tells me 2 plus my missing root should equal negative 5/4. To solve for x, let's subtract that 2. So we get negative 13/4. Let me just check my work before I go on so I don't mess up anything else. Yes, negative 13/4. Now to find the product, or to find the value of c, I can find the product by just multiplying my two roots. Negative 13/4 times 2, which is negative 13/2. That tells me negative 13/2 should equal c over a, which is negative 4. Cross multiply. 2c equals 13 times 4, which is 52. Divide by 2, and you get 26. And I did leave one of those for you to practice below, so see what you can do with those later. The next type of thing is writing a quadratic equation with the coefficients that I give you. Now I'm doing the more difficult ones now, At least those last three are the more difficult ones, so I can give you easier ones for homework. What you are first going to do is find the sum and the product of the roots. Well, sum is you add them. Product, multiply. So 7 plus 4 is 11. 7 times 4 is 28. You know that your sum is equal to, okay, what I want you to do here is you come up with an equation. Start with an x squared, please. Change the sum of your roots, you negate it. So instead of being a positive 11, make it a negative 11x. And then for your product of the roots, that goes in the C spot, equals 0. It says integer coefficients in the problem. You just need to make sure you have whole numbers when you're done. If you don't, which we'll see later, you have to do one extra step. So, let's move down to the one below. The sum, add the roots up. 3 plus 3 is 6. I plus negative I is 0. For the product, we have to multiply. So it's going to be 9. Plus 3i minus 3i is going to cancel out. So minus I squared. I squared, say negative 1. So 9 minus negative 1 is 10. So my equation is going to be, start with an x squared, change the sum to negative 6x, and the product keep it the same, plus 10 equals 0. Please make sure you're putting the equals 0 afterwards. If you don't, it's not an equation and I have to take points off for it. Let's move on to the one up here. So the sum of the roots, add the numerators, add the denominators. 1 plus 1 is 2. Or keep the denominators the same, sorry. Radical 5 plus negative radical 5 is 0 over 2, which is 1. For the product, we have to multiply. If I do the denominator first, 2 times 2 is 4. In that numerator, we're going to have 1. Negative radical 5, positive radical 5, the inner terms cancel. Radical 5 times negative radical 5 is going to be negative 5. 1 minus 5 is negative 4 over 4, which is negative 1. So my equation will be x squared. Change the sum to negative x minus 1 equals 0. And we will finally see in this case when we don't have integers for this last problem here. The sum, add them up. 3 halves I plus negative 3 halves I is 0. Product, multiply them. 3 halves I times negative 3 halves I is negative 9/4 I squared. I squared is a negative 1, so that's just a positive 9/4. So we'll start with an x squared. I don't have a sum, so maybe just plus 0x just to show you. And then keep the sign of the product, so plus 9/4 equals 0. I could write this as x squared plus 9/4 equals 0. Notice you do not have integers here, you have a fraction. When you end up having a fraction, what you do is you multiply by the largest denominator. My largest denominator, in this case my only denominator, is a 4. So I'm going to multiply everything by 4. And when I do that, I will have 4x squared plus 9 equals 0. We'll practice more with that concept in class. At this point, you can try the 3 do now problems.